project for our grant proposal in alpine ecology. So some background on why we're performing our research. Here's a quote from the National Park Service that says, Glacier National Park is rich with plants and animals, approximately 1,132 species of plants, 277 species of birds, and 66 species of mammals live here, so there's lots of biodiversity. The result is a mixture of plants and animals that do not usually live together. Alpine environments are among the habitats most strongly affected by climate change, and consequently their unique plants and pollinators are faced with the challenge of adapting or going extinct, and that's by David W. Inouye. He goes on to say that changes in temperature and precipitation affect snowpack and snow melt, resulting in changes in growing season in the environment where plant growth and pollinator activity are constrained to snow-free season, which can vary significantly across the landscape if there's significant topographic complexity.
Yes, and based off of all this, we have formed 3 hypotheses that we're going to work with for our experiment. For our first one, we said as distance from the snowfield edge increases, the number of arthropods present increases. For our second hypothesis, we said as the number of plants present increases, the number of arthropods present increases. And for our third, as snow and or snow melt presence increases, ground temperature decreases.
Now we're going to head to the field to test these things out. So this chart shows how we displayed our data. We collected vegetation type, ground temperature, soil surface, invertebrate, and the amount of invertebrates we found. We did this for each transect, so this is an example from transect 4, which is the 25 meters away from the second snowfield at Pegan Pass. We were able to identify 2 vegetation types at the 9 meter mark and the 10 meter mark, which was silvery basilica and alpine willow. Our highest and lowest ground temperature varied from about 19 to 31 degrees Celsius. A lot of our soil surface was small and large rocks, and we identified 1 invertebrate as seen at meter 16. We continued this process for all 4 transects that we took of 25 meters. Here we have the first transect we recorded at Snowfield Pass on the edge of a snowfield. Our transect was 25 meters long, and we recorded inventory for vegetation, invertebrate presence, ground temperature, and ground cover type at each meter within the 25 meter transect.
Here is an up-close look at one of the soil cores we did. The soil core is about 5 inches worth of soil, and we sift through it to search for any invertebrates. And then we do this once at every point. This is the second transect we took at Snowfield Pass. You can see Arlie recording the temp here. We do this every meter again for 25 meters. This is the second snowfield we found at Pegan Pass, about 4 miles into our hike. You can see the flag that starts our transect. Going along the edge of the snowfield, you can see Arlie taking a soil core to check for invertebrates. This is an example of one of the insects we found along the edge of the Snowfield transect.
One of the vegetation types that we found on our second transect that was 25 meters away from our first at the edge of the snowfield was a silvery basilica.
That is so cool, you guys. Two
This
grizz
is
cubs.
rare. Holy
Two
shit.
grizz cubs.